So this amplifier provides voltage output proportional to the voltage input. So output voltage is proportional to input voltage. So I'm going to say that is going to be the proportionality constant is going to be replaced by the constant called gain. So V out is proportional to V in. Okay. So I'm in a voltage amplifier. V out is proportional to V in, or I can say V out equal to AV into V in. I am introducing a constant of proportionality AV. AV is your voltage gain. V out equal to AV into V in. That is what they are saying here. The gain should be constant and gain should not depend on RS and RL. Whatever source and load resistance you put, gain should be constant. For an amplifier, it should be independent of source resistance and load resistance. Such an amplifier is called an voltage amplifier. So for an ideal voltage amplifier, the input impedance should be infinity and the output impedance should be zero. I told you the reason. Yes, for ideally, there should be no, the input impedance should be very, very large, and the output resistance or impedance should be zero. But practically, Ri will be larger and R naught will be smaller in numerical value. They will not be infinity and zero as it is told by the theory. That is the reason why we impose the condition Ri should be very much larger than Rs and R naught should be very much smaller than RL. Any doubt in voltage amplifier? The circuit diagram and how we relating the circuit diagram with the equation and the parameters what we are finding and the condition for the parameters Ri and R naught. Any queries you have on voltage amplifier? See, if you relate and study like this, then every circuit will become very simple. See, if I give a circuit, you should be able to write the equation. If I give an equation, you should be able to draw the circuit. You should be well versed in both. See, so far what we have done, the circuit was given, we are writing equation from the circuit. But now what we have done, we have written the equation for voltage gain. And from the voltage gain, I am drawing this entire circuit diagram. We are doing the reverse thing. So when circuit is given and you write the equation, it is called a circuit analysis. When equation is given and you draw the circuit, it is called as circuit synthesis. So an engineer should be proficient in both circuit analysis and circuit synthesis. Given a circuit, you should be able to apply the basic KVL, KCL and write the equation. Given a KCL or KVL equation, you should be able to frame the circuit. You should be well versed in both. So for a change here, what we did, we are doing circuit synthesis. So given only two words, voltage amplifier, I am able to draw the diagram and I am able to explain the characteristics without knowing what will be the components inside my amplifier. Yes, so any doubts you have in voltage amplifier, you can ask. I am going to pause for a few seconds. Please feel free to ask any basic doubts you have. Can anybody say what is the best example of an voltage amplifier? Examples for voltage amplifier. What examples you can cite for voltage amplifier? Yes, I need answers. You've studied about voltage amplifiers, right? What examples you can cite?
Resistors RC and RE.
Common emitter and common base are good voltage amplifiers. Okay, so common emitter, you know, it is an voltage amplifier. Common base is also an voltage amplifier. Okay, but common base is not current amplifier because the current gain is 1. It is only an voltage amplifier, whereas common emitter configuration is going to be both voltage and current amplifier. So knowing the trick how to draw the circuit diagram from the name voltage amplifier, we are going to do the same thing for